In this video, I'll summarize the preventive controls that have configured for my Capstone project securing JRT queues AWS landing zone. It is AWS environment. Okay. So currently in this video, I will be tackling with the task 3, which is networking part. Maybe before that, I'll just give a quick glance on the project, what I'm going to achieve, and what are the different phases, and what phase I'm now covering in this video. So this is a capstone project I have created with the intention of practicing real world skills related to AWS security. And the case study background is JRT Cure is a fictional 150% digital health and wellness company. Their products are subscription app plus telehealth platform. So users book the virtual consultations, store their health records, and track fitness data, and they pay via Strike tokenized card flow. So this is their main business, and they need SOC 2 compliance because this is a healthcare information. This app stores healthcare information. It has to be HIPAA compliant, and it has to make sure that PI data is safe, it is not breaching from the S3 bucket, and need to fix broad IAM permissions. These are the main aim of this security project, and also achieve a data classification, PHI, data, PII, confidential and public. Okay, so any telehealth notes and appointments are categorized into PHI, regular names, emails, and addresses PI, and confidential internal financial employee data, public, marketing sites and assets. So then this project is divided into four phases. Phase 1 is about identity and access foundation. Phase 2 is device control, directive controls, and phase 3 is preventive controls. Under the preventive controls, networking is the one I'm currently working, where goal is to have a prolap tier in private subnets only, and security group scope to specific ports, and create a NACL. This is a broad goal or requirements of a networking part. Now we'll come back to the actual section. Actual thing of is, so to secure production application tier handling PHI data according to the requirement, we need multi-layered AWS networking strategy where there would be some public subnets and host application load balancer is hosted in the public subnet. There would be few more subnets, like for firewall is one subnet, and you can have another subnet for internet gateway. That's optional but recommended. And private app subnets where we host production instances, whether EC2 or ECS or EKS pods. And there should be a isolated database subnet where PHI data is stored, which should have a strict NACL controls. This is our architecture overview. So there, for this, let's come back. Let's look at the networking architecture that I have in my environment. So this is a network architecture I have a network account, and in the network account I created a VPC. Under VPC, 3 subnets created: public, private app, and isolated. In fact, there are a couple of more subnets, but in a couple of more public subnets, but just to focus on the requirement of this phase, I will just talk about one subnet, one public subnet. So, the public subnet has a public subnet is have one routing table, so that routes the traffic to the IGB, internet gateway. From there, internet is accessible. Whereas for the private app subnet, there is one route table. It is only for internal routing. There is no external routing from here to internet gateway. And similarly, for isolated database subnet also, there is different subnet and a routing table. But on this routing table, NACL is configured as an extra layer of security. Then every subnet have some security groups with some specific settings, filters. Those security groups will be assigned to the respective resources in the uh, subnet. So let's look at some security groups configuration. There is one ALB security group. This is a public security. This is for public security, public subnet. Like any resources that we create under here will have. This is for resources under public subnet. Let's say NLB or whichever resource you create, and let's take NLB. It is only for NLB. Okay, network load balancing or application load balancing. So for the NLB, port 443 is allowed from the internet, and 80 is allowed from the internet. This is inbound. And for the outbound, 80 and 443 is allowed. Like this is inbound, this one is inbound, this is from here to here. Okay, and this is outbound. Port 80 and 443 is for here. Like application type security group, there will be one security, there is one security group here, there is one security group here. For this security group, for port 80 is open, port 80 and 443 is open. This particular one I'm talking about. Okay, then there is one app security group. As I was mentioning, this is an app security group. In the app security group, 3080 application ports are allowed. From the 3080 ports are allowed from ALB security group. ALB security group. Okay, this is app tier security group. This is inbound. And outbound to the database security group, to the database security group 5432 database port is allowed. Sorry, from app security group to database, 3080 are allowed. Sorry, for database security group 5432, only database port is open, 5432 is open. And from outbound, deny all, nothing is going outbound from here. Okay, and then coming to NACL, another layer security, where This is on the database subnet only. So where 543 5432 database port is open, inbound rule from app to database 5432 is open, and outbound ephemeral ports are open. These ephemeral ports, like when from the application security group any request comes to respond back to application ALB or any applications, these ports are required. So this port should be allowed. This is about the security groups and ALB. And then let's have a look at VPC architecture, where I have in the VPC, I have in the VPC I have 5 subnets, and 2 are three are public subnets. The green color are public subnets, and these 2 are private subnet. One is for storage, one is for app subnet. So these 2 public subnet, private subnets are connected to associated with the route table, private route. It doesn't have any internet connectivity, route to the internet. In fact, because this has to be, yeah, isolated, this should be associated with another routing group, and it should not directly communicate until there are ports open, right? And then app subnet, this one will have a routing group, routing table. Yeah. So but if you look at the public subnets, 3 public subnets are connected to this routing table. This routing table has a route to internet gateway. From there internet access is allowed. Okay, so maybe this one we'll look at a look have a look at in the console. We will get a better picture. I am in the VPC. I will select this VPC. Yeah, so this is my resource map. If you see, all the 3 public subnets are connected to this routing group, 1 2 3 routing group, and it has a route to internet gateway. So all these subnets are associated with this routing group, whereas this subnet is associated with this routing group. There is no internet connectivity, so isolated from the internet. In fact, I have added associated both the subnets into one routing table, but since we want isolated subnet, the ideal thing is to have another routing table and associate this to another routing table. Just have to keep that in mind. So in summary, what I have achieved is, I am not allowing any private applications in private subnet to expose to the internet directly. Only public subnet is exposed to internet. Maybe if some internet is needed for app subnet, there will be some NAT table created. With that, internet network address translation will happen. Private apps will get the private workloads in the privates will get the internet access based on the requirement. It is not implemented, but that is the idea. Then whereas database, we have given a separate subnet for database, which is more secured, which has another NACL layer of security. What is maybe at this point, maybe it is important to understand what is a difference between NACL and security group. Security group is will be associated with the resources. It will control the source level of traffic, and whereas NACL is associated with the subnet, it controls the subnet level of traffic. That is the main difference. Okay, and the routing table, you can see the three different routing tables. Only this routing table has a route to internet.